Now, in a group, all elements have inverses. So let's look at inverses in the symmetric group. Now, inverting a permutation is easy no matter what notation you're using. To invert a permutation in matrix notation, we just transpose the matrix. So for example, 4, 1, 2, 3 inverse is, we'll write out 4, 1, 2, 3. Transpose that, and when we transpose that, we've got the first column, the first row becomes the first column, second row becomes the second column, third row becomes the third column, and the fourth row becomes the fourth column. So this is the matrix of 2, 3, 1, 4. So for matrices it's easy, just transpose. In generator notation, just reverse the generators. So SI1 through SIK inverse is, now in any group, to invert a product, you just take the product of the inverses, but in the opposite order. SIK inverse, SIK minus 1 inverse, etc. SI2 inverse, SI1 inverse. But all of these generators S in the symmetric group satisfy the generator squared as the identity. So each of them is its own inverse. So you just have to write SIK, SIK minus 1. Just write the generators backwards and you're done. So for example, S1, S2 inverse equals S2, S1. And you can see that if you multiply these together, S1, S2 times S2, S1, we've got a cancellation of S2's, which leaves us with S1, S1, and those cancel each other, and they give us the identity, which is the whole point of inverting. The inverse of an element times itself is equal to the identity. In one-line notation, if J is in position I, write I in position J. So for example, if we write a permutation here, 6, 2, 3, 5, 1, 4 inverse is, we see 1 in position 5, so that means we put 5 in position 1. We see 2 in position 2, so we put 2 in position 2. 3 is in position 3, so we write 3 in position 3. 4 is in position 6, so we write 6 in position 4. 5 is in position 4, so we write 4 in position 5. And finally, 6 is in position 1, so we write 1 in position 6. Two-line notation, well, is about the same, but you can think of it slightly differently. So from, let's do the same example, 6, 2, 3, 5, 1, 4. We flip it upside down. 6, 2, 3, 5, 1, 4, 1, 2, 3, 4, 5, 6. And then we can rearrange the top permutation so that it's in order 1, 2, 3, 4, 5, 6. So 1 is first, so we'll write the 1, 5 first, and then we want 2 next, so we'll write the 2 and 2, and then 3 next, so we'll write the 3 and 3, and then 4 next, so we'll write the 4 and 6, 5, so we'll get the 5 and 4, and finally 6, 6, 1. So it does the same thing as what we did with the one-line notation. Finally, for wiring diagrams, well, to do a wiring diagram, we just write it backwards, just like we did with the generators. So if we have this wiring diagram and want the wiring diagram for the inverse, this is S3, S2, S1, S2. Then we just write it backwards. So reflected in a vertical mirror here. And of course that corresponds to writing the generators in the opposite order. So that's about it. Inverting is very easy. The end.